Welcome to section 1.3, linear functions, slope, and applications. So there's got a lot of vocabulary here that I'd like to just talk about. Linear functions are functions that are formed from a straight line. And so linear functions can look like y equals mx plus b, like this, or they could look like y equals 3.5, like this. That's the constant function, like just y equals some number b. It's a horizontal line. There's also other kinds of functions that are not formed from straight lines, like parabolas, y equals x squared minus 2, and like y equals 6 divided by x. This is a function, and it passes the vertical line test, but it's not made up of lines. So there are other things, too, that I wanted to show you. This linear function here is connected by points. It doesn't matter what 2 points you choose, you can find the same slope, and we'll do that later on in this section. Here's another example of a horizontal function. The input is -4, the output is -2. The input is 1, the output is -2. The input is 3, the output is -2. It's the y equals -2 function. Kind of a boring output when it's always -2, but that's what it is. The domain is exactly one. The domain is all real numbers, and the range is -2. It's only one number in the range. Vertical line, this is not a function. It fails the vertical line test. You draw a vertical line here and it touches more than one point. Because, check this out, if the input is 4, then the output could be any number. It could be 5, it could be 0, it could be -3. So this is not a function. Although you can still graph it if you want. You just type into Desmos x equals some number, like x equals 4, and then it'll graph. It's graphable. It's a relation. It's a pairing of input and output values, but it's not a function. Slope. So I hope you've seen this before in other math classes. A slope is, the formula is going to be, there's 3 different versions of the formula. Some people like to think of it as, and sometimes it's more helpful to think of it as the rise over the run. This distance, the rise, over this distance, the run. It could also be thought of as the change in y, like y2 minus y1 over the change in x. x2 minus x1. But if you just want the formula, here it is, y2 minus y1 over x2 minus x1. And it's actually completely equivalent to y1 minus y2 over x1 minus x2. So there it is. If you actually want to find a value of the slope, for example, like this, if you see a linear function, and so, for example, the total cost of quality foods in location A. So if you've got over a period of months the cost in thousands of dollars, you could find a table like this, and then you notice that this is a changing in 10 every time. Change in 10, change in 10, change in 10. But the y values are increasing by 50. So the change in y over the change in x would be 50 over 10. You can calculate that the slope would be $5,000 per month. If you wanted to, you could also just look at 2 of these points, 20, 100, and 70, 350, and this would be x1, y1, x2, y2, and you plug them into the formula. y2 minus y1 over x2 minus x1 equals 250 over 50, which equals 5. Again, $5,000 per month. The slope is often uses the word per, because you have to compare the y units per the x units. 5 miles per hour, 5 kilometers per second, $5 per dog, $16 per day. Whatever it is you want to do, the slope is often going to be using this word per, because you're comparing the two. Now, I do want to say that a nonlinear function, you're not going to be able to easily find that slope, because although the change in x is 10 here, if it's not going in a straight line, then these values are all going to be increasing. They're going to be different. So you're not going to easily be able to find the slope of the entire graph. You could find the average rate of change between any 2 points, and like you could just draw a straight line in between any 2 points that you choose and find the slope of that straight line. But you can't do it. You can't say that the entire graph has one particular slope, because it's changing all the time. I wanted to show you what graphing the function would look like. So if they say to graph the function, remember, I think it's best to go equation, table, graph. So the function is this. It's the f function, and the inputs are, we can choose 0, 3, and 6. I'm actually sneaky about this because I'm going to choose 0, 3, and 6 because I know they're going to cancel out the denominator. This 2 over 3 is kind of hard to graph whenever it's a fraction or a decimal. But if you choose 3, these 3's cancel. If you choose 6, the 6 and 3 cancel. So anyway, when you're graphing these, go equation produces a table, the table produces a graph. And I don't think the table should have just x and y's. I think it definitely should have a column in the middle for the work. It's easy to show work that way. You're more organized and more likely to get it all right, and you show the work in an organized way. I even like to put a little side column over here. You don't have to, but it reminds me that I have to plot the points 0, 1, 3, -1, and 6, -3, as you can see right here. 3, -1 is right here. And because I chose sneaky values of x, I get no decimals in the y. Although if you choose just 0, 1, 2, you're going to get the decimals or fractions as y values, which are not impossible to plot, but they're just harder. Speaking of average rate of change, I was talking about that a little bit. You could technically do an average rate of change between any two of these points and get kind of a slope. But if you ever need to do that on a graph, say like this, obesity among adolescents ages 12 to 19. So depending on what year you're talking about, you would have it gets steeper here, not quite so steep, really super steep right here, and then it averages out. But if you want an average rate of change, then you just find the slope between the two. You can pretend there's like this straight line that connects these two dots, and everything else smooths out, and you find the slope, y2 minus y1 over x2 minus x1, and you get your slope in percentages per year. Now check out Desmos. Road grade. Just a couple more examples. Road grade, it'd be A over B, so it'd be 1 foot over 12 feet, the change in Y over the change in X. And often when you see these road signs, when you're either biking or driving a car, it'll say like 3% or 6%. So that's just A divided by B, and then you change whatever small decimal you get to a percent, and that's what the grade's going to be. All right, so we got some work to do on Desmos. So do what I do on Desmos and make sure you can save the file and show me in class when you get there. Afterwards, you can make sure you do the first problem on the assignment, and I'll see you in class. All right, go to desmos.com and click on the button Start Graphing, and then you can even sign in with Google. That way everything gets saved. Okay, so the couple of things we're going to graph. First of all, let's just type in the formula for slope. M is equal to, and I'm gonna press the division symbol, so we get something on the top and something on the bottom. y2 minus y1. I'm gonna press the down button, I'm just gonna click right here, the denominator. x2 minus x1. Can't really see things very well. I think I'm gonna change it to projector mode. There, a lot bigger. And yes, give me a whole bunch of sliders. Bergman loves sliders. All of a sudden, you will be able to plot parentheses x1 plus comma y1. That's the first point. Sure, give me a label. And then, yes, I said give me a label. Label. Great. Then you can even type the parentheses here if you want. X and then a 2, and then comma y2 and parentheses. Show me that label. Show me that label. There it is. Now, if we animate this a little bit, you can see, so you can just change the values to whatever you want. You can see things go a little differently. And the slope gets calculated right here. M is equal to negative 0.78666, and there it is. I'm going to add a B value too. And B, I'm just going to type in B equals 2. Oh, sorry, 3. I typed a 3. There it is. Can we press play on that? Yes, we can. And as soon as you press play, you get a slider, which can move back and forth. Funny, if you type in y equals mx plus b, it remembers the b value. It remembers the m value that it's calculating here. And so when you type in y equals mx plus b, it already knows what b is and what m is, and then it's going to connect the two. Like that. If b is equal to 0, then we get the exact slope between those. Some other formulas, so you can even change this from y. I want to let you know that it recognizes function notation, recognizes it really well. F of x is equal to mx plus b. Some other fun facts you can do are x equals, say, a, and does it recognize a? No, how does it know what a is? X equals 9, and if you click out of it, then you can see it gives you a slider. X equals something is going to be a vertical line, and y equals 3. Click out of it, and you get another slider also. That's a vertical line. While we're at it, let's do y equals the parabola that you saw. Y equals ax squared plus bx plus c. Sure, let's add all the sliders so that we get parabolas that we can change. Any formula that you want to type in, you can always type it in here, get some sliders, and then have fun seeing what they do when they change. Let's save this as PreCalc 1.3, save, and there it's done.